Day 7 is a review worksheet preparing for quiz 2. So let me just choose to do one problem from each group here so that way we're ready for our quiz today. Okay, let's do, actually the first one probably looks the most challenging here. Log base 3 of 9 rad 3. So I'll change this into log base 3 of, so I'm not allowed a calculator, so I got to think about my powers here. 9 is the same as 3 squared. Radical 3 is the same as 3 to the 1/2. So this is log base 3 of 3 to the 5/2. That's 2 plus 1/2 by our exponent rules. Log base 3 and 3 to the cancel each other out. This one looks like a final answer of 5/2. Type 2, find an inverse. Here, let's do C. We'll do part C. H of x equals log x minus 3. So write y equals log x minus 3. Switch the roles of x and y. X equals log y minus 3. Undo the common log. Undo log base 10. So that's raise both sides 10 to the power of. So over here we have 10 to the x. Over here we get some cancellation, which leaves us with y minus 3. So then, adding 3 to both sides would be y equals 10 to the x plus 3. And so my final answer to make sure I get full credit would be h inverse of x, to make sure we know they're married. 10 to the x plus 3. H inverse of x equals 10 to the x plus 3. Nice. Okay, sketching a graph, asymptote, at least 3 points. We'll do F because that's got the nice little base on it of 1/2. Those take a little bit more work than the average ones. Okay, so now that we've done enough examples here, plus this grid is all messed up. I think the grid got shifted in my copy. Hopefully it's better on the one at home. So I will treat this and this as my axis and ignore the other ones to the best of my ability. Oh, it happened in the bottom one too, so you'll have to do the same thing down here. Okay, well anyway, let's make a t-table. I think I've done it before with functional transformation, so this time we'll do a t-table to help me out. And that means I need to figure out good numbers for log base 1/2 of x. So one number, since that's just an x with no fanciness going on, I'm definitely going to plug in a 1, because log base anything of 1 is nice and easy. I'm also going to use the number 1/2 and the number 2, because I know powers on 1/2. That'll give me 1/2 and will give me 2. Let's do them. 1/2. Log base 1/2 of 1/2. What power do I raise 1/2 to get 1/2? That's 1. 1 plus 1 is 2. So I have to go to 1/2, comma, 2. I can't tell where anything is. So that's an approximate point of 1/2, comma, 2. In fact, I'll label it 1/2, comma, 2. Okay. 1. Log base 1/2 of 1 is 0. 0 plus 1 is 1. So I need to go to 1, comma, 1. So it seems to be about there. And then we have a 2. Log base 1/2 of 2 would be -1, because that we need a reciprocal. What power do I put on 1/2 to get 2? That's a reciprocal. So -1. -1 plus 1 is 0. So when I plug in 2, I've got to get 0. This appears to be my graph. Remember, this is no longer the x-axis. That's just an accident. And my asymptote is right here at x equals 0, because there was no horizontal, or in this case there was no horizontal shift, right? This one's going to have a horizontal shift, but this one has no horizontal shift, so that completes the problem. This is consistent with one of our previous packets where we had a fraction as our base, a number less than 1 as our base, and we saw that it became a decreasing function. Oh, and that's it for today.